What if I told you that your average road trip along I-90 is actually a journey through 1.4 billion years of Earth's history? This isn't just a highway, it is a time machine. And the best part? You don't even need to leave your car to witness some of the most fascinating geological stories ever written in stone. Welcome to Roadside Geology. This series is inspired by the Roadside Geology book series. I highly recommend checking them out for whatever state that you are in. So today we are exploring one of America's most geologically fascinating interstate drives, I-90 between Missoula, Montana and Spokane, Washington. This 200-mile stretch of highway cuts through the heart of the ancient Belt Supergroup, passes the shorelines of what was once the largest glacial lake on Earth, and through one of America's richest mining districts. We're starting this series with this route because I have been fascinated by it for years. When I was living in Seattle and working in Montana, I drove this highway countless times back and forth. But it wasn't until my first time actually stopping and exploring in 2019 that I realized that I was driving through billions of years of Earth's story. So today I want to share that with you. Grab your books and buckle up. We are about to turn your next road trip into a journey through time. Let's go. I don't really know where Google Maps is taking me. I don't know where I can do this that it won't be weird, but we're gonna do our best. Our journey begins here in Missoula, Montana, where evidence of one of the Earth's most dramatic geological events is literally written in the mountains around us. Take a close look at the lines here on the mountainside. Can you guess how they formed? Feel free to pause the video and take a moment to think about it. These horizontal lines on Mount Sentinel and Mount Jumbo aren't roads or trails. They are ancient beaches of what was once the largest glacial lake ever known, Glacial Lake Missoula. Around 15,000 years ago, a massive ice sheet crept down from Canada, blocking the Clark Fork River near the Idaho border. Behind this ice dam, water backed up, creating a lake so large it contained as much water as Lake Erie and Lake Ontario combined. As Glacial Lake Missoula filled and drained repeatedly, waves lapping against the mountainside created these distinct shorelines. Think of them kind of like the rings in the bathtub after you give your dog a wash and they're really dirty and you drain all the water and there's still that line. Same thing. Maybe your dogs aren't as dirty as mine. I don't know. Each of the lines on the mountainside represent a different level in the lake, with the highest reaching about 950 feet above the valley floor. The waves eroded these small terraces into the mountainside and deposited gravel and sand, creating these features that have survived for 15,000 years. What's fascinating is how perfectly horizontal these shorelines are. Water always finds its level, giving us the perfect geological benchmarks of this ancient lake's surface. If you find yourself in Missoula, I highly recommend hiking the M Trail on Mount Sentinel at least once. Actually, if we're being real, once is plenty, just once. It is a great climb from the University of Montana campus, and it crosses several of these ancient shorelines, giving you an up-close look at this geological feature. As we leave Missoula and head west on I-90, we're going to travel through the ancient lake bed of Glacial Lake Missoula. For the next 70 miles or so, our drive will follow much of the Clark Fork River, the same path those floodwaters took when the ice dam broke. All right, at exit 82, watch for an enormous road cut of pinkish-colored sediments. This remarkable exposure contains 36 distinct layers of lake sediments, each representing a separate filling of Glacial Lake Missoula. That's right, this catastrophic cycle of filling and draining happened at least 36 times over about 2,000 years. Between these fine lake sediments are coarser river gravels deposited as the lake drained. The lowest, oldest layer was deposited over a total of 57 years, while the top layer represents a lake that lasted only 6 years, evidence that the ice dam was gradually thinning and receding. If you pull over here on exit 82, apparently there's a historical ranger station and visitor center, which I didn't know about and I've never been to, but we might have to visit sometime. All right, so as we continue westbound between exits 75 and 61, we are entering the Alberton Gorge. This is where the Clark Fork River cuts through solid belt bedrock. This gorge is the channel that drained glacial Lake Missoula during those massive floods. Today, this section is popular for whitewater rafting with Class 3 rapids. The river is still carving through this landscape, though much more slowly than during those catastrophic floods. The beautiful colored rocks that you're seeing along the highway belong to the Missoula group of the Belt Supergroup. This is the youngest of the massive sequence of sedimentary rocks that formed about 1.4 billion years ago. That is billion with a B. I think I'm insane. But check out this coloring. Okay, so these are all part of that Missoula part of the Belt Supergroup. These red and green colors come from different oxidation states of iron in the rocks. All right, so if you get off on exit 61 and take the frontage road and look to your right, you'll see something really spectacular, and it's not gonna look like it. They're just gonna look like these kind of hills in the grassy fields. But what these are giant ripples. Now, these are just like ripples you'd make by dragging your hand through the sand, but these were made by floodwaters so powerful that they created ripples in gravel that could be hundreds of feet from crest to crest. I don't actually know if I can get back on the interstate this way, so we might just be taking a little detour. Big old landslide over there. I don't know if you guys can see it. Big old landslide. So as we approach Superior here at exit 47, we're approaching the easternmost extent of the heavily mineralized zone that follows the Lewis and Clark Fault Zone, which we'll get more into later. This area was once the gateway to one of Western Montana's biggest gold rushes along Cedar Creek. If you have time, the Superior Historical Museum has exhibits on this often overlooked period of Montana history, so I highly recommend checking that out. All right, we are back on the interstate. So at exit 33 for St. Regis, the interstate begins following the St. Regis River through a narrow valley. This straight valley follows that Lewis and Clark Fault Zone. It is worth pulling off with this exit for a very special reason that doesn't really have to do with rocks. Gotta grab a huckleberry milkshake. Yeah, must stop. Okay, now back to cool rocks. Near St. Regis, look for large cliffs with chunks of solid rocks in a matrix of crushed rock that has been bleached to pale colors. This bleaching happened as hot water circulated through the fault zone, altering the minerals in the rock. As we climb toward Lookout Pass on the Montana-Idaho border, we're traveling through the Rivali group of belt rocks. These rocks represent sandy and muddy sediments that accumulated in the shallow water near the shore of the ancient Belt Sea. All right, here at Lookout Pass, we cross the Continental Divide at 4,710 feet of elevation. The Visitor Center here makes an excellent pit stop, and in the winter, it is home to the Lookout Pass ski area. From this point, all water flows west towards the Pacific Ocean, rather than east to the Atlantic or Gulf of Mexico. So as we descend from Lookout Pass into Idaho, we are entering the heart of one of America's richest mining districts, the Coeur d'Alene Mining District, also known as the Silver Valley. Throughout our drive, we've been following the Lewis and Clark Fault Zone, one of the most significant geological features in the Northern Rockies. This isn't a single fault, but a 30-mile wide swarm of faults running northwest to southeast over 200 miles. Unlike the more common up and down moving faults, these are primarily strike-slip faults where rocks slide horizontally past each other, similar to California's San Andreas Fault, but on a smaller scale. I have a whole video on the San Andreas if you want to dig into that itself. Geologists believe that the zone has experienced at least two major movement periods, one about 70 million years ago and the other about 50 million years ago. The fault zone here acted kind of like a natural plumbing system. When deep, mineral-rich fluids heated by ancient volcanic activity needed somewhere to go, they flowed through these fault fractures, cooling and depositing valuable minerals like silver, lead, and zinc. This is why nearly all of the mines in the region follow these fault lines. The faults literally paved the way for one of America's greatest mineral treasures. Between the 1880s and today, the Coeur d'Alene mining district has produced over 1 billion ounces of silver, more than 80% of all ore ever mined in Idaho. The district has also produced thousands of tons of lead and zinc, along with gold and copper. I highly recommend taking exit 61 to Wallace, Idaho, the self-proclaimed silver capital of the world. Be sure to park downtown and check out the Center of the Universe manhole cover at the intersection of Bank and 6th Street. The Wallace District Mining Museum and Sierra Silver Mine Tour are both within walking distance and offer fascinating glimpses into the area's mining history. I actually have a whole video coming out about spending the perfect day in this area, so if you're interested in hanging out here, be sure to check that out for all of my recommendations and tips. Another important stop in the Silver Valley area is the Sunshine Miners Memorial at exit 64. You take the exit and turn right, and it is right here. You can't miss it. This memorial commemorates the 91 miners who lost their lives in the 1972 Sunshine Mine disaster. This was the United States' worst mining disaster since the Granite Mountain Speculator Fire in 1917. The Sunshine Miners statue is a moving tribute to the human cost of mining. As we continue west past Kellogg, we're following the remarkably straight valley of the Coeur d'Alene River, which runs along the Osborne Fault. This major fault is a part of the Lewis and Clark Fault Zone and played a key role in mineralizing this region. West of the mining district, the landscape opens up as we approach Coeur d'Alene Lake. You can take exit 22 at Wolf Lodge Bay for a spectacular view of this glacially influenced landscape. Coeur d'Alene Lake fills a basin formed by the combination of faulting and glacial action. The Purcell Trench, which contains the lake, was further shaped by glacial ice during the Ice Age. As we cross into Washington, we begin to see evidence of yet another major geological event, the massive Columbia River basalt eruptions. The Columbia River basalt eruptions were among the largest basaltic floods in Earth's recent history. Between 17 and 6 million years ago, enormous fissures opened in the Earth's crust, not releasing explosive volcanoes like Mount St. Helens, but vast floods of liquid lava. Some individual flows traveled over 400 miles from their source. They cover parts of Washington, Oregon, and Idaho, creating what geologists call a large igneous province. These eruptions dramatically transformed the landscape, filling in ancient valleys and creating the relatively flat Columbia Plateau that we see today. As we drive through the Spokane Valley, we're only seeing the top of this massive stack of cooled lava flows. Through the Spokane Valley, watch for road cuts where you can see the dark Columbia Plateau basalt flows. These younger volcanic rocks overlay the much older belt rocks we've been following for most of our journey. Also be sure to keep a close eye out. In some places, you can actually see columnar basalt, which is really cool. The final stop I recommend, but I did not visit on this trip, is the Bowl and Pitcher area at Riverside State Park, just 10 minutes from downtown Spokane via exit 280. Here, the Spokane River cuts through basalt formations, and enormous rounded boulders, some the size of cars, lie scattered about. These are ancient pillow basalts, where the upper lava flow came into contact with the lake water, which quickly solidified it on contact. These weren't carried here by the river we see today, but by the catastrophic glacial Lake Missoula floods that swept across eastern Washington when the ice dam broke. The $10 day use fee for Riverside State Park is well worth it for the close-up view of these flood features. The suspension bridge here gives you the perfect vantage point to see how water continues to shape this landscape today, though on a much smaller scale than during those Ice Age floods. This 200-mile journey from Missoula to Spokane has taken us through 1.4 billion years of Earth's history. What looks like just another interstate highway drive for a road trip is actually one of the most accessible geology classrooms in the entire country. So the next time you drive this route through I-90, I hope you'll take a look at it through new eyes. These boring road cuts actually contain ancient seabeds from before dinosaurs walked the earth, ancient shorelines from Ice Age lakes, and even a river that follows a fault zone that concentrated some of America's richest mineral deposits. I would absolutely love to know if you liked this series, and if you did, what highway should we explore next? I am always looking for the next road trip. As always, we have a ton of other geological adventures, so be sure to subscribe and check those out, and I will see you next time. Until then, keep exploring the stories written in stone.